Let's start. So welcome, ladies and gentlemen. So today we will present you Groovy Head in the Cloud. But first, let's present ourselves. I don't think you have there is a need for. Cedric, but still.
So, I am Cedric Champeau. Probably you already know me since it's my third talk in this conference. So just quick, I'm a Groovy committer and a specialist of AST transformations. And the reason why I am doing this talk with Fabrice is that before I worked on some topics which are discussed in that talk especially. So with regard to safer scripting in general.
So I am Fabrice Matrat. During the day I'm working as a web architect for Amadeus, building a 120 website for airlines. And on evening I'm part of the Three Musketeers, building mobiles plugin for Grails, also co-founder of the Riviera GUG, and committer on Kujo.js, the Spring.js framework, and an active member of the JavaScript user group in Sophia Antipolis. So, Cedric.
Yes, so the reason for this talk is that a few months ago, Fabrice invited me to a hackathon day in Nice, so the city where it is. And the objective of that session was to produce some code for the Groovy community. So in this talk, I'm going to explain how we can potentially do the same, and Fabrice will show you the results of that day. And what really interests me in that topic is that this is something that you can do also. I mean, contributing to Groovy is not that hard. You don't have to be an expert at Groovy. You just need some key features that I'm going to show you. So, of course, I am not speaking of small contributions like just fixing typos in the code, fixing Javadocs, etc. For that kind of contribution, of course, you can do it yourself. I am talking about contributions that really impact the language, add features to the language, or add new libraries, etc. So those for which you alone wouldn't be able to do without some expertise from people from the Groovy community. So in general, what happens is that during your daily job, you identify some problem and you try to solve it in Groovy. Often you find some solutions to that problem, but those are specific to your company, to your maybe just solving a small part of the problem just so it is. But still, you have identified one problem to solve. And for some reason, you are thinking that this is something that could be part of the challenge. So, really the key is to identify that problem that you want to solve and you want to share a solution with the community. So, the picture is a bit dark. So, the next slides are just some pictures of the hackathon day. So this
Cedric.
is me in the background. Oh.
Okay. You're back.
Okay. So this is me in the background, and the idea is that don't do that alone. Try to find some mentor. So in this case, Fabrice invited me, but it can be someone with some expertise of Groovy in your city, in your local user groups. Whatever, try to find someone who will take some time to help you and to guide you during the session. Not to write the code for you, just to help you write the code, which is very different. I mean, I didn't produce a lot of code in that session, but I gave some things on what you should write and what you should not write. So a mentor basically is the idea. Try to find some experts, invite them, don't be shy. Next. So, of course, have to do some work. So I think we spent maybe 4 or 5 hours coding non-stop code. And the idea is that during that session, you will find more problems to solve. And the solutions that you thought were good ones will probably not be good ones. So during that day, since you are a group of friends, a group of people working together, you will identify sub-problems to solve. And this is important because for big features, obviously in one day you will be able to solve the whole problem. Next. Really, if you're engaged in such a day to work, it shouldn't be a pain. I mean, it's all a pleasure. In that case, it was on the weekend, so after work, you just want to gather with friends. It shouldn't be work. It just should be pleasure, and just for your own pleasure to increase your knowledge of the language, but also increase your ability to share experience with others and eventually share the results of your work. So this leads me to the last slide. Pull request is important for us in the Groovy community. In the end, what you produce in the day needs to be published at some point in the form of a pull request. But it's not important if you don't manage to do that the first day, because we did that in February, if I remember, and we still don't have a single pull request for the feature because it was too big. So it's not because you have finished working in a day that you have finished working at all. When you start something, try to go until the pull request stage, because you will, it will be, yes, for you, just for you, it's much better to have the idea that you finished your work. And eventually, even if your mentor is not someone from the Groovy committers, can be someone from your local group of experts, you would have feedback using a pull request, feedback about your work. Okay, so now the problem.
So the use case. One of the things is we can use Groovy inside the cloud, inside cloud application. And typically, in Amadeus, what we were doing is using Groovy for customization and on your web application. So we were able to provide customization to travel agent who can modify the behavior of the website, and some domain-specific language to help them to provide some business logic. So that was an example of what you can do inside the cloud. So what we were doing is really build a script execution environment where they could modify really the way not only of the application logic works, but also the render on the UI. And we developed some specific API for them to ease their work in Groovy. So that allows 500,000 travel agents to be able to modify the website they are working with. There is other case, like for example in Jenkins, you can customize your build inside the, with here some end command, which are executed part of the build. So there is different way of customizing website in the cloud. One of the main issue we found with that was that script can be written by anyone then, and they are not developers by themselves. So they can write scripts that can consume resources, so eat 100% of your CPU, do a lot of I/O using a lot of threads, and also they can access any of the Java API and your own API maybe. So they can access your data model and can access your database then. So that's the main issue of using customization and script inside web application. So there is already some solutions which are existing to deal with those problems. So Cedric, I think it's you who did the ThreadInterrupt, for example. That I'll let you explain the ThreadInterrupt.
The idea of ThreadInterrupt was that usually in an application you can run a script on a thread and you have another monitoring thread that you want, for example, to run for several seconds, and if the script hasn't ended, you want to interrupt the script, okay? So, because, yeah, it consumes too much resources. So the problem with typical code like that, while true, is that even if you interrupt the thread, it will continue to run in the background, because thread.interrupt doesn't interrupt the thread. It just sets a flag on the thread saying, I'm interrupted. But it's the user code and the user who has to check that flag to interrupt its process itself. So basically, no use. And when you annotate a script with ThreadInterrupt, it will just add some code that does the check of that flag, and then it exists properly.
So the next one will be, there is other annotation. There is a time to identify a time in second. So after 10 seconds, your script will be stopped. So that's another way of controlling the time execution of your script. One more is the conditional interrupt, which allow you to avoid like infinite loops inside coding. So it will go inside the script, and here it will count how many times a loop is invoked. That's a great way to control then threading and CPU, but what about API control? So imagine someone inside the script does system.exit. So today inside the Groovy script, your application is on the cloud and someone writes a script and does a system.exit. Do you think what's happening? It just stops. It does stop the application server. It's working fine. It does exactly what it's supposed to do. Yeah. So Cedric wrote something around securing at compile time your script. So I'll let you speak a bit more about it.
Yes. So this is the very reason why I was chosen as the mentor of this specific issue. So not because I was a Groovy committer, because I wrote that. So the SecureASTCustomizer is something that allows you to limit the grammar of the language. So you will provide some limited syntax to the users. So in SecureASTCustomizer, the important part is not secure, it's AST. So my bad for choosing such a bad name, but it's not that secure, and that's the reason why we did that. So in this example, the only thing that we're doing is setting a blacklist saying if something is called on the system class, it's just not a load. But very important to understand, it's based on the AST, so abstract syntax. That means on the grammar side, at compile time. so not runtime.
So what's happening here is that the Groovy shell which is invoked will throw a security exception, in fact. So that's all fine, we're all happy, but there is an issue. Here, what I can do is, for example, I cast system as an object, and I'm still using the SecureASTCustomizer, and do you know what's happening here? It's crashing again, because it's not my presentation which is crashing. Ça va m'énerver. So here, basically, you are not forbidding to use object. So you can use object, and because at runtime it will be resolved to really system.exit, but it will be only at runtime, not at compile time. At compile time, it will be an object where the method exit is called.
The really important part is this one, and this is the receiver. The receiver of the message is a cast expression. It's not a class. It's a cast.
You also use introspection to invoke system exit.
In fact, do you know how many ways there is to invoke system exit? Who thinks there is like 3 or 4? 5?
Give numbers.
Give numbers.
Don't be shy. How many? 11.
I stopped. In fact, I didn't come up with that list. It's Jim Driscoll who put a list together, and he says that's just a few ways of calling system exit.
There are more.
There are more. So there is many ways. So you can't do that really fully at compile time with Groovy, basically. So that's where we were working. And we looked at what was existing already inside the community. So there is, we found 4 different kinds of implementation to be able to secure script at runtime. So one was done by Kosuke Kawaguchi, who is the Jenkins, the main committer on Jenkins. So it's called the Groovy Sandbox. We had a really nice talk last year at GreatConf US by Jim Driscoll, where they are doing the same thing inside Oracle ADFm, but their code is not open source. A few months back, there was Simon Temple who proposed also a solution. And there is a solution which is linked to more the security manager, which is called the Java Sandbox. So you think with all those solutions, there is no need to put something new. One of the problems is that most of those solutions are using the mechanism around call side caching. And in particular, they are using a method that will be removed in the next version of Groovy. So those solutions will not work for the next version of Groovy, and they are not working even today for invoke dynamic or static type checking. So we wanted to put something in place that will work with all of that. And the solution we found was to wrap, for example, this call, we wrap it inside a closure during with AST transformation. So during compile time, the idea was to really take every call and wrap them inside a closure and invoke something like this Groovy access control class that will check that on this receiver you can really call this method with those parameters, and then calling the closure if it's possible.
Is that clear for you? Because this is really the key point of this solution. So it's an indirection of invocation. instead of directly invoking method, we need to check and invoke.
So the check by itself is working, as we say, on the receiver with the method name. And what we have is a set of blacklist or whitelist of methods. And we really check on the receiver if this method with those arguments is either on the blacklist or either on the whitelist. This method check call on receiver will throw a security exception at runtime if it's not allowed. If it's allowed, it will call the closure, which wrap the original call. So that was the solution. And that's where we work with Cedric during the Hackengarten. And the result is that today we have something where we can show you. So here I take an example where, so there is a secure run. No, it doesn't want today. I think I need to switch off the Wi-Fi. That will be easier if I know to do that.
Can you switch off the Wi-Fi on the Mac?
Okay. So, sorry. Here, there is a Groovy shell that we instantiate where we put the configuration link, in fact, to the. And sorry.
Maybe just before you explain that example, are you familiar with the way of executing a script in general in Groovy from within an application? This way, I mean, with Groovy shell dot evaluate or whatever. Yes? No? No opinion?
Usually use compiler configuration.
Yes.
Yes.
Okay.
So that's the compiler configuration, which is PaaS, whereas we have set the customizer on it. And here, there is a script, and what we would like to do is only authorize forbidding the usage, for example, of array list clear, the method clear on array list. So here we cast the array list as an object, so it won't be checked by the normal SecureAST customizer, but we have the secure runtime AST customizer now.
Yes, and just the question. So the magic is that configuration includes the customizer. So it's done with the base class.
Yes, sorry. So here we authorize the construction of an array list, but we don't authorize the call of the method clear. So if we run this test, it will work. I can even show it to you today. It's working.
You have to change it to prove that it's working.
There is a test which is passing, which throws a security exception, and basically it says that the method clear is not allowed. So there is the same way of, you have the blacklist. So here you specify what you want to block. Cedric always says that you should only work with whitelist, but if you look like, for example, someone like Koshke says that you should always work with blacklist. So there is two opinions. So that's why there is two different ways. So choose your. So it will work in exactly the same way here. It will also throw a security exception with method clear. What was interesting also during that day was to find new ways of, creating classes and hiding things. So here, an example, I go from a mass class. I create from the mass class. I create an array list. Having fun and using the new instance of it. Okay, it's working. Did the method call on add on array list, and it is throwing a security exception. As I said, there is many different ways of creating objects. So one thing I learned was the new IFI annotation. So new IFI, you have to define, you call a method, you define a method, and inside you just use the .new, and later you can invoke this method and it will return you an instance of array list. Here what I have done also is not calling the method directly, but using a string to do the method. So it's quite different way of invoking the method.
So the basic is that people will try to get around the limits. Yeah.
But what happens when we override array list class by some my array list and have some method that's called new add, and we'll call super.add.
It's annoying with work because you have the receiver and your class will be inside the script. The user class will be inside the script, so itself will be modified by the secure runtime customer. So the code that the user will write will be modified. So the super code will be checked.
Okay, but I'm not sure that
If the class is somehow outside of the security customer, okay, you get another limit. But it's written inside the script, it will check itself.
But I mean, even if this override class will be inside the script.
Yeah. But the code that you override is written inside the script,
Yeah.
so we can check it. And you can put some limits inside too.
Okay.
So you can prevent super calls.
What's also important is that there is an indirect way in Groovy of calling methods. So for example, if you use a star dot on a list, it will invoke the string method on every element in the list. So it's an indirect way also of calling method. So we were able also to work with that and it's working fine. It's showing a security exception with no issue.
Yes, and here we have a nice example of how you can block any method call. Just set the whitelist to empty. This means
Nothing is blocked. Not a single method is blocked.
You can define alias, and when you define alias, inside AST transformation, it's not anymore a method call. So here you have array list clear, which is defined as an alias, and you can call this alias. And during the AST transformation, this is not considered as a method call, but as a method pointer call. So here you will have to also have a whitelist for your method pointers, and what you can do, if you want to have the same, you just assign it with the same value. But you might want to just do not allow aliases. So you will put, like before, an empty array for the method pointers whitelist.
Yeah. Basically, I think that if you want to try to secure your scripts, and if you really want to do that, you should be blocking the maximum of language features, and then open wisely what you want to open to users. So typically, a method pointer like this should be avoided because you can do very weird things with that. You can carry, you can do smart things. So I don't think that you should use method pointers. You should allow method pointers inside the scripts if you want to secure them.
Next one also is what you want is sometimes do not allow property access. So in the same way, we were adding properties whitelist and blacklist. So here, for example, you have the class which is available on every object. You might want to blacklist it, I would say, because that's opening the door to a lot of security issues. So class in general should be forbidden in any access around class. So that's a different whitelist, blacklist that we put in place. One more thing will be binary operator. So here, what we put inside the whitelist is we did not allow basically the usage of any array access in the binary operator whitelist. So you can block also operators.
This is getting trickier. You want to check at runtime what is the type of the elements on the left and the right of binary expressions. Because in some cases you want to allow, in other cases not. So the syntax for all the whitelist and blacklist of binary operators is a bit difficult to, you know.
It's a bit difficult because you will have to define a map.
You have to define for the combination of left and right elements. Yes.
Why would that be a security threat?
Security?
Why would that be a security threat? I suppose that your main goal is to close hooks.
Yeah, but potentially in Groovy, any binary operator is also method call. So you can have other reading methods. So for so this is binary operation. So the array index calls getAt, but you have plus, you have minus, etc. And all those need to method calls. And as soon as you get into method calls, you have graphs. So potentially insecure.
So that was some of the example of the different unit tests we put in place that day and that we managed to make run and work. So that's just some of the example of what we did during that day. So today, what's left for we still have a major issue, which is with implicit this inside script.
Explain that.
Yes.
So anybody knows what is the implicit this in Groovy? You all know what is the explicit this. Okay? So in code, if you do this dot foo, it's an explicit this. But you can also write just foo without the this. So in general, this is not a problem, but if you want to secure the script, it's a very big problem, but actually it's not solved by this solution. So let me explain why. We also have closures in Groovy, and closures have the notion of delegate. And in your code, you can have a closure, and inside that closure, a method call from implicit this. And in fact, this method call occurs on some objects. It can be the delegate, it can be the enclosing class, it can be basically anything. The problem is that we don't know at compile time of this call, unless you use compile styling and have delegates to annotation of the closure. But in general, at compile time, you don't know what will be the receiver of the message. But worse than that, with closures and the pluggable resolution strategy, the fact is that the method which will be called, you only know what method will be called because it has been called. You know, it's the meta object protocol of Groovy that works that way. It means that the object doesn't say, okay, I will accept this message. So I will accept a message called foo with those arguments. It doesn't say that. It says, okay, I do the job. Or method not found. So it's only when the method is called that you know it exists or not. So for securing the script, it's a big problem because once you have called the method, it's too late. Obviously, if you have called the method, it's too late. So for me, this led me to think that if you ever allow users to write an implicit-based script, it is insecure by nature. And I was a bit disappointed to discover that myself.
But the main issue on that is, for example, if you have DSL, you really use the notion of implicit this inside DSL and also inside Builder. So we do want to still have support for Builder and DSL inside script. So we are fighting to find something.
Probably the only solution would be to have explicit whitelist and blacklist on what method calls are allowed on implicit lists. But you never know what class will receive the message. When I'm talking about message, it's the object of the message, so it's basically the name of the message.
The other thing is, after that, we will have to look at the static type checking and how to do it. We didn't look at it yet, because we need first to solve the first issue. The next things will be, once that's done, to clean the code, and especially do more and more and more tests. So we need as many tests as we can find. So even if you want to play with us and do some testing around it, you are welcome. And if one day it does go to the Groovy code, you will be a Groovy committer.
And you know that Fabrice lives in Nice, so it's not that far from Spain compared to where I live. So once you invite me, you will have to get them to complete that. We'll be happy.
Yes. And that's it.
Questions?
So, no, but key takeaway. One thing is contributing to Groovy is easy. I just send a mail to Cedric. I met him before, but I just sent him a mail explaining what we wanted to do. He was quite happy to help us. And it was easy. The organization itself, like finding a place, etc., was more difficult than having Cedric with us. Securing your script in the other way is not at all easy. That's a bigger challenge. So what I would recommend is also, even if the runtime check will be completed at some point and you can use it, the way it's also using compile and secure and runtime check together. That will allow you to have better security, and also it's better to catch anything you can during the compilation. And next thing is, if you want to go further, you can use a security manager. So that will be the other solution, and you should consider it.
Just to complete the compile time plus I think it's really important the fact that with Groovy you really have the option to work both at element type, and the ability to combine both makes it a really powerful language.